We've looked at the types of waves and wave characteristics, or the properties of waves. We're now going to look at some of the phenomena that waves exhibit. We'll just do this as a broad overview to begin with, and then we'll look at some of them more specifically in the context of certain types of waves, so whether it's sound or light. And so we'll just jot down some notes about what these wave phenomena are. So waves exhibit the following phenomena, and some of these terms you'll already be familiar with and you'll know what they mean, but we'll just go through them really quickly to begin with. So the first one is reflection. So in explaining what reflection is, we can think of it as being the rebounding of a wave. And when it rebounds, it's rebounding off a surface or boundary. So when we talk about a boundary, we're talking about the limits or the extremes of the medium, and we would sort of identify that it's as the wave reflects, it's going to change direction. And as well as changing direction, it's travelling back into the medium from which it came. So if we think about sound rebounding off a wall, means that the sound wave is bouncing back, and light likewise from a mirror. The light bounces back into the air from which it originated. So with reflection, we'll look at a few different scenarios dealing with reflection, because there's a few properties that, a few other concepts that develop from reflection. The next one then is refraction, and you should have seen this one in I think grade 9 science. So with refraction, it's the change in direction of a wave. And the reason for that change in direction is due to the medium through which it's travelling through. Sorry, change in direction of a wave. So as I said, due to the change in speed, and that's always going to be the case when we move from one medium into another. So as it moves from one medium into another. Now when we're talking about a medium here, it's not necessarily that it's changing substance. So if we think about light, if it's say travelling from air into water, that's obviously a different medium, but we can have refraction occurring in water waves when you've got different depths of the water. So by talking about a different medium, it's not always going to be a different substance. It could just be a different property of the medium, such as the depth of water, or the temperature of air is another example. So light will refract through air that's at different temperatures. The next phenomena then is diffraction. This one's probably new, but you deal with diffraction every day, and it's the spreading out or bending around of a wave after it travels through a small opening or around an object. So the reason why I'm saying that you deal with this every day is that you can hear sound waves around a corner. So the sound waves are actually bending around wall, around the corner that you might be standing near, and so the diffraction can cause waves to bend in that sort of situation. Light is another example where diffraction is important. We're not really going to go into diffraction in much more detail than that, but there is a lot more of a mathematical approach you can take to look at diffraction, but basically we just need to be aware of the fact that waves can bend or spread out after they pass through a small opening or around an object. The last property that we're going to summarise here then is interference. Now interference is the increase in amplitude or decrease, and in some cases it can actually be the complete cancelling out of two waves. So note that we are dealing with two waves for interference to occur, whereas all of the others are a single wave by itself. And the increase or decrease in amplitude, or the cancelling out of the two waves, will occur as they pass each other in a medium. Now, with this idea of interference, we're going to use another principle here. It's known as superposition. So interference is the phenomena itself, but superposition helps us to determine the type of interference that's going to occur. And superposition is just the adding of the displacements of the two waves, or of the two waveforms. So we'll look at this in a little bit more detail in the next video. Sorry, not the next video, the one after that, where this idea of interference, or looking at superposition, is going to help us to understand a few other phenomena that we'll see. And interference, again, superposition again, is when we're looking at waves travelling past each other. So there's the broad brush overview of those phenomena, and as I said, we'll look at some of those in a lot more detail and develop them into look at some equations in some cases, and other phenomena that sort of come out of combinations of these phenomena as well.